Alright, so that first video, we came up with a bunch of solutions that actually worked out perfectly, like they hit right exactly at 2, or right exactly at -4 and -2. Numbers don't normally turn out that pretty, so in the second video we're going to be estimating solutions. So that's what we have here. Often you can't find the exact roots, so we're going to do our best by estimating. So this first example that we're looking at, we're going to solve this by graphing. So pretend we didn't know that we're in this section where we have to estimate. We're going to set this up the same way. And so we are going to graph the related equation. So we're going to graph this. And when we do that, we're doing the exact same thing we did in the previous video. We're looking for x-intercepts. So we start by looking at our vertex. Vertex formula is negative b over 2a. Negative b would be -4, and then over 2 times the -1. So -4 over -2 would be +2. Alright, so we are going to plug this in, set up a table. So our x and y values, remember like the previous video, 2 is kind of our center. So from 2, we're going to go down 2 values and up 2 values. And those are the 5 values we're going to use. Rather than just randomly going from like -2 to 2, we get an idea of what the shape of the graph looks like, and we know it's going to be centered around the vertical line x equals 2, so we're going to use those values. Alright, so I'm taking these x values and plugging them in here. So 0 plus 0 minus 1 would be -1. If I plug in 1, -1 plus 4 would be 3, minus 1 would be 2. Plug in 2, -4, plus 8 is 4, and then minus 1 would be 7. Now this one, 3, -9, plus 12 would be 3, minus 1 would be 2. And then finally 4, -16, plus 16 would be 0, minus 1 would be -1. Okay, so we're going to plot these values. Notice none of these came out to be exactly 0, but we can do the second part, state the consecutive integers. So we're going to graph all these points. 1, 2, 3, 4. Okay, so 0, -1, that'd be my y-intercept right here. 1, 2, 2, 7. 3, 2, and 4, -1. So remember, this is my axis of symmetry right there. So I'm going to connect the dots, make a nice parabola here. Okay, so that's, I should have actually covered through the dots, but that's what our parabola should look like. And then it says state the consecutive integers between which the roots are located. So like one of my roots is located right here, one of them is located right here. When they say consecutive integers, like here, they literally mean between x equals 0 and x equals 1. And then again, we have between 3 and 4. So that's literally all we're going to write. Between 0 and 1. And then between 3 and 4. Okay, so that is about as accurate as we're getting with that one. Let's move on to the next one where we can get slightly more accurate, and I'm going to teach you how to use your graphing calculators for this. So solve this equation. So what I'm going to do is I'm going to graph the related function f of x equals x squared plus 5x minus 7 in the calculator. Okay, so that is what I'm going to show you to do. So follow my lead here. Whatever you're on, whether it's, an old document, new document, if you hit Control and then Doc right here, it'll add a page. And since we're graphing, we're going to go for number 2, the graph page. And now plug that function in. So we're supposed to be doing x squared plus 5x minus 7. Okay, so you get that typed in. It's the exact same equation that we have right here. And then go ahead and hit enter. And when you hit enter, you'll see the graph. All right, so it'll look something like that. So first of all, let's write down our approximations. Okay, so here it's just a little bit past 1. So we know we have one between 1 and 2. Okay, so we're writing down like just our approximations. Okay, and then the next one, this is negative 1, 2, 3, 4, 5, 6. That one's close to a negative 6. Okay, so those are our approximations. I'm going to show you how to use the calculator to actually do that. Give roots to the nearest thousandth. Okay, so the buttons you're going to hit Control first, the blue button, and then T for table. So if you do that, a whole table will open, and it'll show you the values. So notice right now, all it's doing over here is using the integer values of x. We can make it use smaller values. Okay, so what you're going to do is hit Menu. Second option here, Table, so you can just hit the number 2. Edit Table Settings. And then we are going to make sure that we go to the nearest thousandth, which is what they want. So 0.001 is a thousandth. Okay, so go ahead and hit Enter. Oops, sorry, that should be, we do want to start at 1. It should be the table step that we're changing there. Okay, so hit OK. And so now what we're looking for is for an x value that would be really, really close to 0. So if we get close here, we're going a little bit beyond, so we're going to go this way until we hit something that's close to 0. So we're just going to scroll and scroll. Now notice we are getting closer to 0. I'm just pushing this button over and over and over again. You probably can't actually tell. You might be able to hear it. So we're just scrolling down. We're getting closer. We're getting closer. Almost there. Okay, that one looks pretty darn close. Okay, so see how that's the closest one to 0 that we have. So that's 1.140 technically. Okay, so we've got x equals 1.140. So that is to the nearest thousandth, which means 3 decimal places. Now we're going to find the other one. Now we don't want to scroll all the way up to negative 6, so we're going to temporarily change our settings back. Or what we could do is hit Menu again, hit 2 again for table setting, hit 5 again for edit. And now what we want to do is we want to start at negative 6, which is our prediction for our other value. So type in negative 6 and hit Enter. And so it'll jump the table back so we don't have to scroll, because that would have taken absolutely forever. Now if we look here, it's just to the left of negative 6, so we should be going back this way. So the exact same thing is going to happen here. I'm just going to hold it down, watch it scroll, watch it get closer and closer to 0. And so we're going to do the exact same thing again. We're going to wait till it gets super close and basically just find the point that looks like it was the absolute closest. Okay, so we're getting there. Okay, I'm going to slow down now. That looks super close. And now that's a little farther away. So that one looks to be our closest to 0 because we've got 3 zeros before we hit a number. So that is negative 6.140. So notice the relation between these two. They actually have the exact same decimal. So these are our best approximations that we have of the roots. Okay, so that was one way to do it in the calculator. I'll show you one more way that gives you like an exact answer. So this is a little story problem. Talking about a bridge. The deck is 1,053 feet above the river. Marble is dropped from 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water? Use this formula right here. So t is time in seconds, that's our variable, and then h is the initial height. So the initial height, we're up 1053 feet and then an additional 3 feet. So that would be 1056. Okay, so that is our initial height. So we're going to plug that into this formula right here. So h of t equals negative 16t squared plus, and then for h naught we're plugging in 1056. Okay, so h is the initial height above the water. So when it asks how long will it take the marble to reach the surface of the water, that would be a height of 0. Okay, so we want to take this and we want to set it equal to 0, which means when you plug in 0 for what's basically a stand-in for the y variable, that means we are looking for the intercepts. And here it's not the x-intercept, it's actually the t-intercepts, just because we had a change of variables. Okay, so we're going to do a graph again, and we can just add a new one. So hit that control button again and then page, add a graph, and we're just going to plug this equation in. Your variable only accepts x's though, so just replace the t. So negative 16, we're going to do x squared instead of t squared, because again, your calculator will only take x. And then plus 1056, go ahead and hit enter. Okay, so now we've got 2 points right here where your graph will cross the line. This one is the one we're going for, because remember our axis is supposed to be t for time, so negative time wouldn't make any sense. Okay, so I'm going to walk you guys through, so make sure you're either writing these steps down or following along with me. If you want to find this point right here, you're going to hit menu, the menu key over on the right hand side. Then we're going to go down to this 6th option right here, which is Analyze Graph. So on the keypad, you can literally just hit the number 6. And then we are going to find the 0. Remember, 0 is the same as root, X-Intercept, all those other words. So hit 1 for 0. And then you'll be able to use this touchpad in the middle to kind of like move back and forth with that dotted line. So lower bound just means you want to click somewhere to the left of this X-Intercept. So I'm right here. So go ahead and click down. If you press down, you should actually hear a click, and you should see this change to upper bound. Okay, so then you're going to scroll over here, and then go ahead and click down again, and notice it like catches an X-Intercept. So your X-Intercept is right there. That's the X value. We know 0 is the Y value because it's on the X axis. So when we solve that, we got 8.12. So we've got t equals 8.12, and that would be in seconds. Since it's a story problem, we should make sure we keep the context. So that would be your answer. It says, how long will it take the marble to reach the surface of the water? So the marble gets dropped, comes down, comes down, comes down. That represents the surface of the water, and the value of h should be 0. Okay, that's it.